For our second day with chain rule, we're going to combine it with product rule. So on day one, we did chain rule just with power rule, because power rule is basically our easiest derivative rule, and that was a good introduction to chain rule. But what you guys are going to see is as we start combining chain rule with more and more rules, we do, chain rule with power rule, we're going to do chain rule with product rule today, and then for the next lesson, we'll add in quotient rule. And as you start to add in more and more and more, it gets a little bit more complicated. So what you want to do is focus on one rule at a time. Ask yourself for each question, what am I doing first? Is the first thing I do power rule, product rule, quotient rule, and then really focus on that one rule. But what's going to happen is within that problem, like when we're doing product rule today, you have derivative of the first times second plus derivative of the second times first. Well, each of those two mini derivatives within your problem might be another chain rule or another power rule or both. So stay organized. And one thing that can really help you is if you start to get too messy in a problem, do the little parts off to the side. Do the work off to the side, figure out what that answer is, then come back and put the final answer into your original problem. Instead of trying to do all this work in this big, big, big messy problem, you can get confused, you can get lost. It's easier if you do the little parts off to the side, and then once you know what that derivative is, you just put it back in your original problem. So for most of today, I really want to focus on examples, show you how to do some of this. And let's start with this one right here. We're going to find the derivative of 3x minus 7 to the fourth power times x plus 2. And remember what I said, for this type of question, before you start doing any work, stop, pause for a second, and just say, okay, what rule am I doing first? And what I see first here is product rule. So I'm thinking to myself, this 3x minus 7 to the fourth power, that's really my first function, and I'm multiplying it times the x plus 2. So this is going to be a product rule question first. So don't worry about anything else yet. Just think about what you know about product rule and set that question up. So we have f prime of x equals. Now product rule is where we do derivative of the first function. And what I'm going to do as I'm setting it up, if I kind of look at the problem, the derivative of the first function is going to be a chain rule. I'm going to leave myself a little extra space for that. Derivative of the first times the second plus, and then everything else should be easy. Derivative of the second times first. So, and I'll write it out. Derivative of the first function times the second one plus derivative of the second function times the first one. So let's fill in the easy parts. The second function is x plus 2, and the first function is 3x minus 7 to the fourth power. Now the derivative of the second is also very easy. That's actually just 1. Derivative of the second function is 1 here. And then our extra work for this problem, and we recognize at the beginning, is when I go to take the derivative of 3x minus 7 to the fourth power, that's a chain rule question. So that's one of those where I might do that off to the side. I'm going to go off to the side here, and I'm going to find the derivative of 3x minus 7 to the fourth power. And then once I've done that work, I'll just put it in those square brackets right there, and I'll continue my problem. So when I look at this question, I think to myself, this is a chain rule with power rule question like we did on day 1. So I can do the power rule to that exponent, but at the end I have to do chain rule. I have to multiply by the derivative of 3x minus 7. So let's do that. When I'm doing chain rule with power rule, I take the thing that's being raised to the power, in this case the 3x minus 7, and I just leave it alone at first. Just recopy it. And then what I'm going to do is I'm going to do power rule around that thing. I'm going to multiply by 4 and lower the exponent by 1 and get 3. But see, that's not your final answer. You also have to multiply by the derivative of whatever that thing was inside the exponent. So basically the derivative of 3x minus 7 is just 3, because the derivative of 3x is 3, and the derivative of any constant like negative 7 is 0, or basically it just disappears. So to finish cleaning this up, I can multiply the 4 and the 3, and what I get is 12 times 3x minus 7 cubed. And that's what I'm going to put here. All right, so what you can see is by doing that work off to the side, now it's my original problem is cleaner. I don't have this big messy thing written in that first yellow block parentheses that I have to clean up later. I've done the cleanup work. I've just gotten that derivative, and I'm ready to move on with my original problem. So let's do that. Let's go back to the original problem. If we basically just clean this up a little, the first piece I'm not going to do anything to. It's just 12. We'll get rid of some parentheses, but it's 12 times 3x minus 7 cubed times x plus 2. And the second piece, I don't need that 1. It's basically just 3x minus 7 to the 4th power. Now, for now, this is fine for an answer. If you gave me this for an answer, I would accept it. That is the derivative. That's f prime. But I'm going to show you a trick that's going to be very useful as we move on in the class, because we actually have a common term here. I have a 3x minus 7 cubed, and I have a 3x minus 7 to the 4th. So when you have a common term, it can be factored out. And the reason this is going to be useful later is because later in the year, we're not just going to be taking derivatives, we're going to be taking derivatives, setting them equal to 0 and solving. And when we're ready to do that, this is the step to do that. So let's look at it now, because it's a good habit for you guys to start thinking about this now. If you see the 3x minus 7, the common term, and you say, well, let's just factor it out. And what I can do is I can actually factor out 3x minus 7 cubed. When you have a common term, you can always factor out the lower exponent. You're basically saying, I got 3 of them here and 4 of them here. I can take 3 out of both of those things. And what's left over if you do that? On the first piece, the 3x minus 7 cubed is completely gone, but it leaves the 12 and the x plus 2. On the second piece, I started with 4 3x minus 7s. I got rid of 3 of them, I have 1 left. So basically what you have is just 3x minus 7. And now let's distribute the 12 there. And you get 12x plus 24 plus 3x minus 7. And if you combine your like terms in the second set of parentheses, you have 15x plus 17. And that would be it's actually the better answer. So remember, the one I boxed up in yellow, that's fine. I will accept that as a correct answer. But as we move on through the year, the white one is the better answer. And it's a good habit for you guys to start looking for things like that now. All right, let's do one more example. The second example is kind of interesting. It's one of those questions where there's 2 ways to do it, and one way is definitely easier. So what I want to do is I want to start it the hard way, just to kind of show you the amount of work it would take. And then I'm going to stop in the middle. I'm not going to finish it. At one point I'll stop and then we'll finish the easy way instead. So let's start off by saying what I want to do first. The first thing I notice here is this exponent on the outside, this 5. And I want to say, I want to do the power rule here with the chain rule. So I'm going to set it up for that. I'm going to say f prime equals. Now when you do power rule, remember you start by leaving the thing that's being raised to that power exactly as it is. So it's x plus 5 cubed times x minus 3 squared. And then I'm going to do the power rule around it, meaning I'm going to multiply by 5 and lower the exponent by 1 to 4. But then you have to do the chain rule part. So I need to multiply by the derivative of what was inside the parentheses, which is all of this here. Now, if you start to do that problem, you can see why I say this is so much work. If I start to take the derivative of x plus 5 cubed times x minus 3 squared, it's a product rule question, and you have the derivative of the first one times the second one, plus the derivative of the second one times the first one. And each of these derivatives that goes here and here, you have to do chain rule again, and you get this big messy thing, and that has to be cleaned up, and then that has to go to the original problem, and that has to be cleaned up. This is what I was saying. This ends up being a ton of work. So I'm going to stop here. I'm going to start the question over, and we're going to simplify first and then make the question a little easier. All right, so here's our question again. Now what I'm going to do here is I'm going to realize I have a product, the x plus 5 cubed times the x minus 3 squared, and that's being raised to a power. Now as long as it's a product, as long as it's not two things being added or subtracted, I can basically just distribute that exponent. I can say I'm going to raise, let's leave it as f of x for now. I'm going to take that x plus 5 to the third power, and I'm going to raise it to the fifth power. Now the rule for that, when you raise a power to a power, you multiply, and 3 times 5 is 15. And then I'm going to do the same thing with the x minus 3. I have the x minus 3 squared, I raise it to the fifth power, 2 times 5 is 10. So now I don't have that chain rule and then product rule, I just have product rule. So let's go ahead and answer the question now. Now that I've taken that extra step to make it a little bit easier, let's find f prime of x. And it's going to be the derivative of the first function. I'm going to leave a little extra space for that because that's going to be chain rule, times the second one, which is just x minus 3 to the 10th, plus the derivative of the second function, I'm going to leave a blank for that one again, times the first function, which is x plus 5 to the 15th. So now we just have to take each derivative separately and kind of fill in the blanks there. So I'm going to do the work off to the side. Let's do the derivative of x plus 5 to the 15th power. And I'm going to say, let's do the power rule. So I'm going to leave the x plus 5 for now. And I'm going to do the power rule around it, meaning I'm going to multiply by 15 and lower that exponent to 14. And then I'm going to do the chain rule. I'm going to multiply by the derivative of x plus 5, which is actually just 1. That's an easy derivative. The derivative of x is 1, and the derivative of 5 is 0. So what I get up here is 15 times x plus 5 to the 14th power. All right, now for the second one, I'm doing the derivative of x minus 3 to the 10th. And it's actually, the work is going to look very similar. It's power rule again, so I'm going to leave the x minus 3. I'm going to multiply by 10 and lower the exponent by 1. And when I do the chain rule, I actually get 1 again. That's kind of nice. It was easy for both of these. The derivative of x is 1, and the derivative of negative 3 is 0. So what I'm going to get here is 10 times x minus 3 to the 9th. All right, now I'm going to finish up the question. I'm going to go through. We're going to get rid of some of this. Clear ourselves some space. And let's clean this up a little. So what I have, let's kind of just stack everything together. I have 15 times x plus 5 to the 14th times x minus 3 to the 10th. And then I have 10 times x minus 3 to the 9th times x plus 5 to the 15th. So what I have now is some common terms that we want to factor out. So if I look at this, what I have here, I have some x to the fifths here and here. And remember, you can always factor out the lower exponent. So I can factor out x plus 5 to the 14th power. Okay, then I have some x minus 3's here and here, and I can factor out 9 of them. Now I'm going to go one more step, although this is kind of an optional step. I have a 15 here and a 10 here. I can actually factor a 5 out of there also. So let's do that. Let's factor all of these out and see what's left over. So for my first term, the first three underline the blue, red, and green there. 15 divided by 5 is 3. The x minus 5's all disappear. I started with 14, I factored out all 14. And then for the x minus 3, there's going to be 1 left. I started with 10 and I took 9 out. Okay, then on my second part, I did 10 divided by 5. That gives me a 2. I took all the x minus 3's out. There were 9. I took all of them. And this time there's 1x plus 5 left, because there were 15 and I factored out 14 of them. So all we got to do is clean up that last block parentheses there. And I'll do that by distributing the 3. That would give me 3x minus 9. And I'll distribute the 2. That would be plus 2x and plus 10. And if you combine your like terms, your final answer for this one, let's leave all this from the beginning. For my last one, I would have 5x plus 1. So this right here is my final answer for f prime of x. It was kind of a messy problem, but remember what I said earlier in the notes. Focus on the rules, remember what you're doing, and then use that extra trick at the end where if you see some common terms, factor them out. That's a good way to clean it up.